Okay, welcome you all. Today I'm going to discuss the significant figures. Okay, first of all, before discussing significant figures, we have to know some other uh, lessons. What are them? We have to know about what is the minimum value of a measurement and what is an error of a measurement. So there are two things we have to know previously before starting the significant figures. What are them? The minimum value. Minimum value of a measurement. And the second is error of a measurement. You have to remember it. The thing is you have to remember is that the minimum value is not the error of a particular instrument. Here I'm mainly focused on chemical instruments, glasswares mainly, burette, graduated pipette, and measuring cylinder, like that. And also we can use a ruler and other so many measuring devices we have. For example, I will take a ruler. Imagine this is a ruler. Imagine it's not a ruler, but just imagine. Okay. In ruler, centimeter ruler, they partition into centimeters, calibrated. So here, between these two lines, actually they indicate here 0 and 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter, 5, and go on. However, we take as an example, we will take 1 centimeter portion of this ruler. I will enlarge it and draw it again. Okay, this portion is 1 centimeter part of the above ruler. In the mid of the centimeter, we can see 0.5 centimeter mark. 0.5 or 5 millimeter, no? However, 1 centimeter portion again divided into 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Here 0, here 1. Okay. Now, in this centimeter ruler, according to this scale, what is the minimum value? Minimum value means the minimum value you can read by using this particular instrument, ruler, or the scale of the burette, or graduated pipette, or measuring cylinder, anything. There is a scale, and by using that scale, we can measure a particular value up to this minimum value. So what is the minimum value? This part is the minimum value, no? So what is this? What's the value of this minimum part? Is 1 part of 10 millimeters. These minimum values are 1 part is equal to 1 millimeter in centimeter ruler, millimeter. So there are 10 millimeters. The minimum part is 1 millimeter from 10 parts. So what is the minimum value? Here, 1 part is the minimum value. There are 10 parts in the whole scale. The scale means within the centimeter, within a centimeter. So the minimum value is 0.1 centimeter. So that's mean 1 millimeter. That's the minimum value. So what is the error? Error is not same as minimum value. To get an error of a measurement, particular measurement, there is an equation, very common equation. Error is equal this minimum value is divided by 2. Is divided by 2. For this example, what is the minimum value? Is 0.1 centimeter. We divided it by 2. So the final outcome is 0.05 centimeters. This is the error. When we indicating an error, we have to put always plus and minus mark, plus or minus. For example, imagine we got a length of a pencil as 10.00 centimeter. But as a science student, we can't put this value alone. We have to always mention the error. So what is the error? 0.05 centimeter of this ruler. So we have to put our measurement as like this, 10.00 plus or minus 0.05 whole in within brackets. Units are common. So this is the final answer. You have to always mention the error with your measurement. That's the correct way. Okay. So these are the basic things we have to learn before starting significant figures. Okay. I will clean the whiteboard. So one thing you have to remember, this error calculation, minimum value divided by 2, is applicable for general analog instruments like ruler or our normal measuring devices in laboratory, burette, like that. So however, we can't apply this equation for digital values. For example, you get a voltmeter reading by using a voltmeter. So it's a digital screen. we can't apply this equation for digital measurements. Please remember that. Okay. For digital values, the instruments by doing some experiments, and sometimes the instrument is self provide the minimum value. However, these values, this equation can be applied for general or traditional instruments like ruler and burette, graduated pipette, measuring cylinder, like that. Those are, we have to take the measurement. We are the doer, so not the instrument. So remember that. Okay. There is one thing, another thing you have to remember. When we express our measurement value, the decimal places here, we put 2 decimal places. Always the decimal places of our answer should be equal to the decimal places of our error. If the error contains 3 decimal points, we have to put 3 decimal points in our answer. Remember that. Answer is X. There should be 3 decimal points because the error contains 3 decimal points. And another thing you have to remember, error should have only 1 digit. Except 0, the error should have only 1 digit. Here 5. We imagine by using a calculation, we got the error as 0.025. Okay, 0.25. This is the error, calculated error. But we can't put two digits as the error. We have to round off to 1 digit. So how can we round off this value? There are some rules for round off. What are they? Here, imagine this is the error, 0.026. No problem. There isn't any matter. We can easily round off this 6 to 2. This 6 is greater than 5. Doesn't matter. We can get 1 for 2. So we are adding 1. So the error is 0.03 because 6 is greater than 5. If that second value 0.023, what about this? Or 24, what about this? This 4 is lesser than 5. So we can't round off. We have to keep it as it is now. So what is the error now after rounding off? 0.02. We can't round off now because 4 is less than 5. If it is higher than 5, we can round off like this. But what about if the value is 0.025? What are the rules? There are 2 things you have to remember. What? Remember this thing. If the digit in left side of the 5, this rule is applicable only for when there is a 5, which is by using that 5, we have to rounding off. At that situation only we can use these rules. Okay, if the digit in the left side of the 5 is odd, we can round off. doesn't matter. What is the first rule? If the digit in the left side of 5, imagine this 5. Left side mean here 2. Left side ekkena, the left side one is an odd number. Is an odd number, we can round off, doesn't matter. What is the second rule? If the digit in left hand side of 5 is an even number. So even number, if it is an even number, we can't round off. Those are the two major rules we have to use during rounding off process. The left hand side is an odd number. So according to these two rules, what is the result of this after rounding off? This 0.025. This is 5. The left hand side of the 5 is 2. 2 is an even number. If it is an even number, what is the rule? We can't round off. So we can't round off. We have to keep it as it is. So what is the reason? The rule. So what is the final answer? 0.02. We couldn't round off. However, imagine next matter is 0.035. Now 35 or 55. 0.055. Now we have to round off to first digit. So that digit is 5. 5 means it's odd or even. It's an odd number, no? Odd number. If it is an odd number, we can round off. So according to first rule. So after rounding off, the answer is 0.06. These are the two rules you have to remember. And one other thing you have to remember, what? The error should contain only one digit. However, there is an exception for that also. What is the first thing? The digit. The error must contain only one digit. Only one digit. That means not zero, non-zero values. Okay, non-zero values. Value. However, except one thing. What is that? The error must contain only one digit. Non-zero value, only one non-zero value there should be in the error reading. However, except one. It's obvious non-zero values, but if the error is 1, we can't put 1 all alone. We can't put only 1. Can you understand? That means, imagine this is an error. 0.00114. As I said previously, the error must contain only one digit according to this. So if you round off this, 4 is less than 5. So final answer is 0.001. However, error can't be 0. Sorry, error can't be 1. We can't put 1 alone. That's the principle. If the error is that digit is 1, we can't put it alone. We have to consider the next digit also. What is the next digit? 4. So we have to put that value also, 0.0014, because we can't put 1 alone. We have to consider the next digit, which means right hand side to 1 also. For example, again I will write another example. You will understand that also. Imagine the value is 0.0135. Okay. Another example, 0.0115. What is the answer for this example? Here, first of all, you have to round off. After considering the result, you have to think this rule. Here, the left hand side of the 5 is 1. 1 means it is an odd number. If it is odd number, we can round off. So here 5, we round off, we get 1, we add 1, 0.02. Now 0. Here 2, 1 digit, 2 is okay. From 2 to 9, we can keep alone. 2 to 9 values, errors. From 2 to 9, we can keep alone. However, 1 can't keep alone. Remember that. Okay. Here it is the 2. We can keep it as it is. However, consider about this. Here, we have to keep only 1 digit. So we round off. Here 3. We can't round off because it is less than 5. Here we round off. We can't round off. So we have to put it as 0.01. However, 1 can't put alone according to this rule. There should be another digit adjacent to that. That digit is 3. So we have to put 3. Before keep 3, we have to round off. The adjacent number is 5. We have to round off now. So 5, again we have to consider these 2 rules, major rules in rounding off. The right hand side, left hand side of the 5 is 3. It is an odd number. We can round off. So we get 1, we add 1. So final answer is 0.014. We can't keep only 1 because as a rule, 2 to 9 digits can keep alone as a single digit. However, if that error digit is 1, number 1, we can't keep it as it is. We have to consider the second digit also. So here second digit is 3. By rounding off, adjacent number is 5. Applying first rule of the rounding off, we have to keep this value as the answer. I think you can understand this. If you don't understand, please leave a comment in the comment section and I will explain to you. And again, I have to ask you, please subscribe my channel. I will upload so many lessons which are very common in chemistry, major chemistry, and some biology and other videos I will upload, but major thing is chemistry. So as a help, please subscribe and like my channel and share with your friends. Okay, that's a very small commercial advertisement. However, this is the end of the part, rounding off and minimum value and error.